In this video, we're going to talk about how to find chemical formulas from experimental data. And this is done in laboratories all the time where you have a substance, and you don't know what it is, and so you need to do experiments to figure out what the formula is. And we have a protocol to do this. And so let's say you have ibuprofen. And you know ibuprofen has a mass percent composition of carbon 75.69%, hydrogen 8.80%, and oxygen 15.51%. So the first thing you want to do is you want to assume you have 100 grams of your substance and convert these percentages into grams. So they should all add up to 100. That's why we use 100 grams. So if we had 100 grams of ibuprofen, we would have 75.69 grams of carbon, 8.80 grams of hydrogen, and 15.51 grams of oxygen. Now the second step is to convert grams to moles using the molecular mass like we talked about before. So the molecular mass of carbon is 12.01. So with 75 grams, we would get 6.302 moles. Hydrogen, we would get 8.02 moles. And oxygen, we would get 0.9694 moles. Step 3 is to write a pseudo formula or fake formula using the moles as subscripts. So we would get carbon 6.302 moles, hydrogen, that should be 8.02 moles, not 8.73, and oxygen 0.9694 moles. Next, divide all these numbers by your smallest number, which is 0.9694. And so we would get carbon 6.5, hydrogen 9, oxygen 1. However, we can't have half of an atom, so we need to multiply the subscripts if they're not whole numbers. So 6.5, we want to make this a whole number. The easy way to do that is 2. So we get C13H18O2. And I have a bunch of multiply by this if you have a certain subscript, so 0.2, 0.25, 0.33, 0.4, so on and so forth. But if you can't remember that, just try to multiply by 2, 3, 4, and 5. If you have to go higher than 5, you've likely made a mistake in your math. Also, when doing this, you might get a number that's 0.98 or 0.02. Feel free to round if it's that small, round down or round up. So let's test your understanding of this. So let's calculate the empirical formula from the following data. 1.651 grams of silver and 0.1224 grams of oxygen. So pause the video, figure out the empirical formula, come back when you have an answer. Alright, let's take a look how to do this. So this is going to be dimensional analysis again. So we have 1.651 grams of silver. Now, looking at the periodic table, we see that for every 107.86 grams of silver, we have 1 mole of silver. Grams of silver cancel out. We're left with moles of silver. And so doing the math, we get 0.01531 moles of silver. Let's do the same thing for oxygen. 0.1224 grams of oxygen. 16 grams of oxygen per mole of oxygen. Do the math, we get 7.650 times 10 to the minus 3 moles of oxygen. Again, watch out for sig figs and for units when doing these problems. So we write out our pseudo formula. We have silver 0.01531 and oxygen 7.650 times 10 to the minus 3. Divide each number by the smallest number and we get silver 2, oxygen 1. So we don't have to do anything further because they're both whole numbers, and that would be our answer. Now, let's say you have this empirical formula, but you want the molecular formula. And you can only do that if you know the molar mass of the compound before you do anything else. Because the molecular formula is just the empirical formula times some constant n, 1, 2, 3, etc. So for example, I have a compound that has the empirical formula of CH. I know the molar mass of this compound is 78.11 grams per mole. So what is the molecular formula? Well, I know from the periodic table carbon is 12.01 grams per mole. Hydrogen is 1.008 grams per mole. And my empirical formula is just CH, so I add these two numbers together to get 13.02 grams per mole. I need to solve for N. So remember, N is molecular formula equals empirical formula times N. Or I could do molecular weight equals empirical weight times N. So my molecular weight is 78.11. My empirical weight is 13.02. Divide the two, I get 6. That's what N is. So I multiply each number here. Since I don't have a number, that means it's 1 by 6 to get C6H6. Now, let's test your understanding again. So find the molecular formula for the following compound with the empirical formula C4H9 and a molar mass of 114.22 grams per mole. Pause the video, come back when you have an answer. Alright, let's take a look at this. So for carbon, we have 4 of them. Molar mass is 12.01, so our molecular weight is 48.04, or our empirical weight rather. Hydrogen, 9, multiplied by molar mass, 1.008. Empirical weight, 9.072 grams per mole. Add these two together and we get 57.11 grams per mole. Now take our molecular weight divided by empirical weight, we get N equals 2. Then we multiply this 2 by the 4 and the 9 to get C8H18. And that's how you solve those types of problems. Alright, so one of the ways you can do this in the lab is through combustion analysis. That is, you take your compound and you just blow it up, and then you measure the amount of H2O and CO2 that was absorbed. And this is really good for carbon, hydrogen, and oxygen compounds. So let's look at how we would actually do a calculation using combustion analysis. So let's say we have a sample and we blow it up, and we know the sample only contains carbon and hydrogen. And we produce 1.60 grams of carbon dioxide and 0.819 grams of water. What's the empirical formula for this compound? So we know the molar mass of carbon dioxide is 44.01 grams per mole carbon dioxide. We can figure that out from the periodic table. Water molar mass, 18.02. So what we need to do is we need to convert grams to moles. So we take our 1.60 grams of carbon dioxide, and we know the molar mass, so 44.01 grams of carbon dioxide is 1 mole. So we get 0.0364 moles of carbon dioxide. And let's look at the formula, CO2. So for every 1 mole of CO2, we get 1 mole of carbon. So this number is actually 0.0364 moles of carbon as well. For water, we have 0.819 grams of water. Multiply it by 1 mole of water for every 18.02 grams of water, and we get 0.0454 moles of water. Looking at the molecular formula, we see for every 1 mole of H2O, we have 2 moles of H. So we multiply this number by 2 to get the number of moles of hydrogen. And we get C.0364 and H.0908. We divide both these numbers by the smallest number, which is carbon, and we would get CH2.5. Now we can't have fractions, so we multiply each number by 2 to get rid of this 2.5, and our empirical formula is C2H5. Again, let's test for understanding. This one's going to be a little more difficult because it has oxygen in it as well. So combustion analysis of a 4.30 gram sample of butyric acid produces 8.59 grams of carbon dioxide and 3.52 grams of water. What is the empirical formula of butyric acid, which again contains only carbon, hydrogen, and oxygen? You may want to look in your book for this one, but Try and figure out the answer. Come back when you have one. Alright, let's look at how to do this. Dimensional analysis. We're going to start with the carbon dioxide. We have 8.59 grams of carbon dioxide. We know the molecular weight of carbon dioxide is 44.01 grams of carbon dioxide per mole of carbon dioxide. We know for every 1 mole of carbon dioxide, we have 1 mole of carbon in the actual formula. Therefore, the number of moles of carbon we have is 0.195. Do the same thing for hydrogen. 3.52 grams of water. Molecular weight of water is 18.02 grams of H2O per 1 mole of H2O. For every 1 mole of H2O, we have 2 moles of hydrogen, again, in the formula. Therefore, the amount of moles we have are 0.391 moles of hydrogen. So we dealt with carbon, we dealt with hydrogen. Now we have to deal with oxygen. So, from our carbon, we had 0.195 moles of carbon. For every 1 mole of carbon, we have 12.01 grams of carbon. So in our 4.30 gram sample of butyric acid, 2.34 grams of that weight are due to carbon. How about hydrogen? How much of this weight is due to hydrogen? Well, we have 0.391 moles of hydrogen. 1 mole of hydrogen is 1.008 grams of hydrogen. Therefore, the weight of hydrogen in this sample is 0.394 grams of hydrogen. Now we should figure out how much oxygen we have in this sample, because all we have to do is take this 4.30 minus the amount of carbon and the amount of hydrogen added together, which is 2.73, and we have our weight is 1.57 grams of oxygen. Okay, dimensional analysis. 1.57 grams of oxygen. For every 16 grams of oxygen, we have 1 mole of oxygen. Therefore, we have 0.0981 moles of oxygen. Time to use these 3 mole numbers and write our pseudo formula. So our pseudo formula is C.195, H.392, O.0981. Divide each number by 0.0981, and we get an empirical formula of C2H4O. So that's it for this video. See you in the next.